Hello friends, welcome to Crackit CSE, and in this series of computer organization and architecture, our today's discussion is based on signed data and overflow flag, that how this overflow flag works, what are the conditions for this overflow flag, what is positive overflow and what is negative overflow. So if you have not subscribed the channel, please subscribe the channel and press the bell icon so that you can get an update whenever I am uploading any new video. Now let's start with the signed data. So the signed data is by default considered as a 2's complement because the signed format and 1's complement format is not used because of the unbiasing that I have discussed in one of my previous videos. So if you have not checked the previous video, please check them out as well. So what is the range of the 2's complement format? So the range of the 2's complement varies from minus 2 to the power n minus 1 to 2 to the power n minus 1 minus 1. So the value which is less than 0 is considered as negative and this one is considered as positive. The value which are exceeding this positive value comes under the positive overflow, and if the value exceeds this particular negative condition, that means the value is less than this particular range, then it is considered as negative overflow. So if I talk about 4-bit range, if I place 4 in this place of n, so this will be 2 to the power 4 minus 1, that is 2 to the power 3, which is 8. So minus 8 to plus 7 is the range. Now unlike the signed data, here we are having the overflow flag. In the signed we are having the carry flag which represents the exceeding condition. Here we are having the overflow flag which used to hold the range exceeding condition of the signed data, right? So what is the condition of this overflow flag? So is there a carry into MSB and no carry out of MSB? So if this is the case or vice versa is the case, in that case the overflow flag will be set or reset. So let me just give you an example over here. Let's say I am having two values, plus 7 and plus 7, and I have to add these values. If I am adding these values, it will be plus 14. What if I convert in the binary? It will be 0 1 1 1 because we are talking about the 4-bit, right? In 4-bit 7 is represented as 0 1 1 1. Similarly the second 7, right? Now we have to add these value. So if you are adding this value, this will be 0 with 1 carry, this will be 1 with 1 carry, again this will be 1 with 1 carry. So this carry which is coming on this MSB bit is known as in carry, right? So if we add this 1 0 0, it will be 1. So there is no out carry, so we can say that this is X. So this is in carry and this is out carry. The carry which is coming into the MSB position is known as in carry. The coming out of the MSB bit is known as out carry, right? So is there a carry into MSB? Yes, there is a carry into MSB. And no carry out of MSB? Yes, no carry out of MSB. That means there is a overflow. So overflow is set for 1, right? Now here you can see that the value is plus 14, which is somewhere here. So we can consider it as positive overflow. How we can know that this is positive overflow will be explained using this particular expression. Just wait for a while, right? Now let me discuss the negative overflow as well. So let's say I am having two values, minus 8 and minus 8, and I have to add these two values. So what it will be? It will be minus 16. And if I convert it in the binary, it will be 1 0 0. Similarly, it will be 1 0 0. And if you add it, it will be 0 0 0. That means there is no in carry. So there is no in carry. And if I add this 1 and 1 will be 0. And there is 1 out carry, right? So if there is in carry and there is out carry, then this condition is known as negative overflow. So the overflow flag will be set for 1. So if the carry is in the format 1x, that means no in carry and out carry, it is negative overflow, right? And if there is in carry and no out carry, then it is positive overflow, right? So remember this thing, this will be very important while you are justifying the particular solution. Now you can see this particular table. So I hope you got an idea about the condition. Now let's see this particular table. If both in carry and out carry are 0, then there will be no overflow, because you can see here only these two conditions holds for the overflow flag. If both are 1 and 1, then also there is no overflow. That means the operation has to be XOR. If we perform the XOR operation between these two, then this should be equals to 1. If this is the case, then we can say that the overflow flag is set. So if it is 0 1, so we can refer it as 0 1, and we can refer this as 1 0. So for both of the cases the overflow is present, so the overflow bit is 1. Now what is the condition? What is the expression? So we can represent the overflow expression as OV XYZ. So what is X? X is MSB of operand 1. So here this one was operand 1 and this one is operand 2. So this particular value X is the MSB of operand 1, this 0, and this particular 0 is the MSB of operand 2, and this 1 is the MSB of result. So these are X, Y and Z, right? So if the X and Y are 0, you can see these are the 0 and Z is 1, then it is positive overflow. And if X and Y are 1 and Z is 0, like this, X and Y, so X is the MSB of first operand, Y is the MSB of second operand, and Z is the MSB of the result. So X is 1, Y is 1 and this is 0, then it is negative overflow. So this is the pattern you should be aware of. Now let us discuss first some examples so that you can have a complete grip on this particular topic, right? So what is 7 plus 3? So plus 7 plus 3, if you add these two values, will be getting plus 10, right? So plus 7 in 4-bit can be written as 0 1 1 1 and plus 3 can be written as 0 0 1 1. Now if we added 1 and 1 will be 0 with 1 carry. 1 1 1 will be 3, that means 1 will be here, 1 will be here. This 1 and 1 will be 0 and here will be having 1. So this is in carry, right? And if we add this, this will be 1. So there is no out carry. So we can consider it as 0. Now you can see that what is the pattern? 0 1, that means in carry is there but out carry is not there. So can we say that this is positive overflow? So the overflow bit is equals to 1 and we can say that this is positive overflow, right? So you got an idea about this expression. Now what if you have to justify this? So to justify this, we will be having a PSW register which will be having accumulator and flag. So the flag is set as 1, but along with this flag value we will be having the status of this particular flag, whether it is positive overflow flag or negative overflow flag. So here we will be having this details, right? X bar, Y bar, Z. So using this particular detail we will be getting an idea whether it is an overflow flag positive one or the negative one. And this accumulator will be having this value 1 0 1 0, right? Now if the overflow flag is 1 and it is positive, then we will be adding the complement of this overflow at the MSB position. So this 1 0 1 0 will be same because this is positive overflow. So I will be complementing this 1 and placing it here, and then when we change it will be equals to 10. So if it is positive we will be adding the complement of overflow if it is 1. If there is no overflow then there is no issue. Let's check the second example. So plus 7 minus 3 is equals to plus 4, we knew it. And if you perform the addition over here, so 1 plus 1 will be 0 and 1 carry, 1 and 1 will be 0, this will be here. Now this is 3 and 1 in carry. Now if we do 1 plus 1, 1 plus 1 will be 0 with 1 out carry. So here you can say that both of the values are same, that is 1 and 1. So if both the values are 1, that means there is no overflow. So overflow is equals to 0, and if overflow is equals to 0, then in the PSW, in accumulator I will be having 0 1 0 0, and in flag overflow will be equals to 0. And if this is equals to 0, that means that the accumulator is having the correct result, right? So there will be no need to justify. In example 3, this is minus 7 plus 3. So minus 7 is written in 2's complement, because we are by default considering the 2's complement. So the every value which is having a negative sign should be considered as the 2's complement. So what will be the value of minus 7 in the 2's complement? We can write 7 as 0 1 1 1. We have to find out the 1's complement, which will be 1 0 0 0. Then you have to add 1 to find the 2's complement. So it will be 1 0 0 1. This is what we have written over. So this is the minus 7 in 2's complement, and 3 is same as this. Now we have to add this. So 1 and 1 will be 0, 1 carry, 1 and 1 will be 0, 1 carry, this 1 will be here. So there is no in carry. So can I write it as 0? Now this 1 and 0 will be 1. That means there is no out carry as well. So here also you can see that there is no overflow. So overflow flag will be reset, right? So this will be minus 4 and this will be minus 4, right? Now similarly, let's quickly move on to the example number 4. So this is minus 7, this is minus 3. Minus 7 can be represented in 2's complement by this, and minus 3 can be represented like this. You can just let me tell you that as well. So the 3 can be represented at 0 0 1 1. We have to find the 2's complement to represent it in the negative form. So it will be 1 1 0 0. Adding 1 to it, it will be 1 1 0 1. So 1 1 0 1 is the representation for the minus 3, which is here. Now we have to add this. 1 and 1 will be 0. 1 will be here, this 1 will be here, this will be 0. That means there is no in carry. 1 and 1 will be 0, and this is 1. That means there is one out carry. Now if both the values are different, then we can say that there is an overflow. So it is confirmed that this is overflow. Now what kind of overflow is it? Negative overflow or the positive overflow? So here you can see that I am having the value as 1 and this as 0. So it comes under the negative overflow, right? So it is negative overflow, and this will be minus 10, right? Now we have to justify this as well. So again we are moving on to the PSW, which will be having accumulator, which is 0 1 1 0, and flag value as 1, along with the status X Y Z bar, so that one should know that it is negative overflow. XY, because this is 1, this is 1, this y, that's why it is XY, and this is 0, that's why it is Z bar, right? Now if this, okay, sorry, this one will be 1, right? So whenever we want to use this particular value, we will be going to the overflow flag first, and if it is 1, that means this particular value is not correct, because this is negative overflow. So what we should do now, this time we will be adding 1 in the MSB place along with this accumulator value, right? And now if you convert it, it will give you the value as minus 10. So this is the 2's complement representation. So you have to convert it to the 2's complement first. So it will be 0 1 0 0 1, right? And if we add 1 to it, it will be 1 0 1 0, which is 10, and this overflow tells that this is the negative value. So you can see that this 10 is same as this 10. So for if it is a negative overflow, that means we have to use this value exactly here and find out the 2's complement to get the actual value. But if it is a positive overflow, we do not need to do anything. We just need to complement the overflow bit and add it to the MSP place, right? So I hope you got an idea how the things are working in the particular signed format. In the next video, I will be giving you around 3 questions which are very important for the signed data format. So thank you very much for your time, and keep supporting, keep learning. Have a great day.